In this short video, we're going to discuss how to approach a calorimetry problem. Remember, when you perform a calorimetry experiment, there is heat transfer between two substances, and that's going to be our approach for solving this problem. We're going to focus on one substance at a time. So first we have 85 grams of an unknown metal, that's one substance, and it's heated in a 95°C water bath. So we're going to assume that's the temperature of the metal, that it's been sitting in there long enough that the temperature of the water bath is the temperature of the metal. It is added to a calorimeter that contains 99.6 milliliters of water at a temperature of 23.5°C. That's going to be our other substance. So in our calorimeter, we're going to have our metal and our water. Thermal equilibrium is reached at a temperature of 35.6°C. Remember, heat transfer will continue until both substances are at the same temperature, and that's called thermal equilibrium. And then finally, we want to solve for the specific heat capacity of the unknown metal. So because that's what we want to solve for, we're going to look at the metal last. Let's focus on the water first. The water experiences an increase in temperature. It goes from 23.5°C to 35.6°C. So that's why we're going to use the equation Q equals mc delta T. We're going to be able to solve for the heat, specifically how much heat is absorbed by the water. The mass of the water is going to be 99.6 grams. The density of water is 1 gram per milliliter. So with 99.6 milliliters, that's equal to 99.6 grams. Then we need the specific heat capacity for the water, 4.184 joules per gram per degree Celsius. And now we want to calculate our delta T. Remember, always final temperature minus initial temperature. So when you calculate this out, you get 5,042 joules. I'm not going to round this number right now. The number is a positive value, which makes sense because heat was absorbed by the water in the calorimeter. That will give us a positive value for heat. Next, let's focus on the metal. The metal also experiences a change in temperature. It starts at 95°C and it ends up at that same 35.6°C. So Q equals mc delta T will be our equation. In a calorimetry experiment, we assume that the heat that is absorbed by the water is equal to the heat that is released by the metal in this case. And so I took the number 5,042 and I put that in for Q in my metal equation. Now I did make it negative because we're talking about heat that is released by the metal. And then I filled in the mass and the delta T. We're solving for C, the specific heat capacity of the unknown metal. So once you do the math, round it to 3 significant figures, you get 0.999 for the specific heat capacity. And then remember, the units for specific heat capacity are joules per gram per degree Celsius. And that's your final answer.